Now the topic is array ADT, that is array as abstract data type. Abstract data type means representation of data and the set of operations on the data. Now array is a basic data structure provided by almost every programming language, like C++ provides a array as a basic data structure. So representation of data is defined by the compiler itself. Now the operations on the data is not given by the compiler. We are supposed to implement the operations or provide the operations on array data structure. So data structure array and the set of operations together, we can call it as ADT. So basically we will be learning how we can perform various operations on an array. So here is the list of operations that are possible on an array, and many more operations are possible. So some of the operations here we will discuss in this video, and more operations I'll show you in the coming lectures. Now I will quickly read out just the set of operations here: displaying an array, adding or appending an element in an array, or inserting an element at a given index in an array, deleting an element from a given index, searching for an element in an array, then getting an element from a given index, knowing what is the element present at a given index, and set, that is replacing an element at a particular index, then finding maximum or minimum, reversing an array, and also shifting and rotation of an array. So we'll discuss all these operations and see how these operations are performed on an array, and also we'll analyze them. Now first of all, let us look at the representation of data of an array. So the first thing is we need an array space of some size. So let us take an array of some size, that is array of size 10. Here is an array of size 10. Now the question is, how will you create this array? There are two methods of creating this array, that is statically inside the stack, or we can create it in a heap. So one method is, I can declare a normal array, let us say array of size 10. Now this will be creating an array of size 10. Whenever I run my program, the size of the array will be 10 only. No, I want to create an array of desired size. So for that, you can take a pointer and later you can create an array of required size. I'm writing a C++ syntax here, so it's easy. Instead of writing malloc function, I'm writing just new. So new of size, whatever the size you want to mention. So we can have the size of an array. Let us say size of an array is 10. So a 10 size array will be created. So we have two options for creating an array. If you are following this one, then you must mention the size. If you're following this one, then at runtime you can take the size and create an array from heap. So this option is better for creating an array of required size. So let us assume that we have taken a pointer and created an array. So here A is a pointer pointing to this array. So two things I have completed, array and size. So if you know the size, then you can create an array of required size at runtime from heap. So this is an array creation. So I have written the piece of code for creating an array. Now the next is length of an array. See, I have an array of size 10. It's not necessary that I am using all 10 spaces. I may be having few elements in that one, or I may be using all spaces. So possibility is there that I may or may not be using all spaces. So I want to know presently how many elements are there in an array. So for that, we should also have one more property of an array, that is length. Right now nothing is there in an array, so let us say the length is 0. So I have completed data representation. So I have an array and two more properties, that is length and the size of an array. Now let us perform these operations on this array. Yeah, this section is about array and the operations upon an array. So I will create a new project for array, and all the operations that we are going to learn, I will write them inside the same project, that is inside the same program. At the end of the section, we will have a single program containing all the operations on arrays. So I will start a new project with the name array. create a project. And here is the main function. First of all, I will define a structure for array. In this, we need three members, that is an array itself for storing the number. So I will take a integer type pointer. So this will be an integer array. And the second thing is size. And the second thing is size. And then the number of elements inside the array, let us call it as length. So these are the three members of a array structure. Now here inside the main function, I will create a variable of type array and also initialize it. So first of all, array ARR is the array name. Then for creating an array, I should know what is the size of an array. So let us take it as input from keyboard. So I will give a message here, enter size of an array. Then read input from the keyboard using scanf. I should read the value in ARR, that is inside this array, the member size. I should read size ARR dot size, and this should be prefixed with ampersand. Yeah, with this we'll be knowing the size of an array. Then once we know the size, we should create an array for this pointer. This is just an integer type pointer. It can point on an array. So we create an array inside heap, then we will make this a point on that one. Here we are able to create an array of our required size. So I have taken the size. Now I will create an array of same size and I will make a point on that one. So say a assign integer type pointer, then malloc function multiplied by size of integer. This a is inside ARR. Now because the malloc function is present in stdlib.h, so I should include that header file. So here I have included header file. Now the following things are initialized. I know the size of an array and I have created an array inside heap and making pointer a point on that one. Then I should set the length to 0 because there are no elements right now. So this is what we need in initialization. So this array will be created in heap. So this type of array structure is more preferable because the size is dynamic. Whatever the required size is, you can take the size. If you want to fill the elements, then you can take the elements from the keyboard or anywhere else. You can bring the elements and fill them in this array. Let us fill few elements in an array and then I will write a function for displaying an array. So for taking numbers, I should know how many numbers are going to be inserted so that I can take them from keyboard. So I am taking variable n. And also for for loop, I need a variable I. Here I'll give a message, enter how many numbers. Enter number of numbers. Then using scanf, I will take the number of numbers in variable n. Now using for loop, I will take all the values from the keyboard and I will store them in an array. I assign 0, I less than n, and then I plus plus. Then scanf, read the elements in an array. So for that, I have to say arr dot a of I, and I should give its address. So here it should be ampersand. Now before for loop, it's better if I give a message that enter all elements. Yes. This for loop will read all the elements from keyboard and store them in an array from starting location to n. After inserting all the elements, I should set length of an array as n because I am inserting n elements. Now here I will write down function for display all the elements of an array. It should take a structure array. Let us call parameter name also ARR. Then it should simply display all the elements. So for that it needs a variable I for using for loop. So it can give a message elements are, then slash n, new line. Then using for loop, I will display all the elements here. I assign 0, I is less than ARR dot length, whatever the length is, then I plus plus, then printf percentile d with a space ARR dot A of I. And here inside main function, I will call display function by passing ARR. Let us run the program and test it. Here, enter the size of an array. I will say 10. Number of numbers, I want only 5 numbers. Enter all the elements. So 2, 3, 4, 5, 6. And this display is displaying all the elements here. 2, 3, 4, 5, 6. Here I have inserted all the elements. Then here display is displaying all the elements. Let us debug the program and see how these elements are stored in an array. I'll put a breakpoint here where I am inserting the elements in an array, that is filling the elements in an array, and I will run the program. Enter the size of an array. Size of an array is 10. Enter the number of numbers, 5. Now it has entered in debugging mode. If you look into this debug area, if I expand this array, it is just showing array object. If I expand this array, it is having array pointer that is pointing on some valid address, and the size is 10 and length is initialized to 0. So these are the things already I have finished till here. Right? Then if I expand this A, I cannot find anything. A is a pointer, it is pointing on the first element, and that element is 0. If I fill the elements, let us see what happens. I will continue. Enter all the elements. First element is 7. Yeah, you can see 7 here inside this debug area, that is inside watch. 7 is there. I'll continue. Next element, 8. I cannot see 8 anywhere. See, A is a pointer, it's pointing on an array in a heap, so it is pointing on the first element and it's showing just first element. 8 is just beside 7, so I am unable to see it. As the array is in heap, it will not show all the contents of an array, it is showing a location where pointer A is pointing. So I can continue and fill up all the rest of the elements and also display them. So here inside the debug area, we are unable to see an entire array. Okay, I will stop the program. Remove breakpoint. Now I have another option for discussing the topics. So instead of taking an array pointer, I will change it to an array of size 20. Instead of taking a pointer and creating an array in heap, I am taking a fixed size array. So I will be using this example that is easy for me for explanation purpose. So I will modify the things here. See, I don't have to create an array in heap now. and even I don't have to set all these things. I will remove this part. Now when I am creating an array, at that time only I will directly initialize it inside the object. See, the first thing is the elements. So initially I will fill the elements, that is 2, 3, 4, 5 and 6. I have filled the elements. The next is size. The size is 20. We have given the size as 20. And the number of elements are 5. See, this structure will be initialized with the values that I have given. So the first part is stored in an array, and the second 20 is the size of an array, because I have already mentioned the size here 20, and then 5 is the length of an array, means the number of elements in an array. So directly I have taken a fixed size array, so directly I have filled the values in the declaration and initialization part. So here even I don't have to take all the elements, I will not take all the elements, directly I will call display function. Now I don't need these variables. See, the program code looks very simple so that it's easy for you to understand. I have an array already initialized, then I am calling display function. So let us go to display function. Display function is displaying all these elements. Yes, perfect. So I don't have to modify display function. Let us run and see what happens. Yes, it is displaying all the elements, that is 2, 3, 4, 5, 6. It's perfect. And if I debug this, will it be showing all these elements that are from 2 to 6? Let us check. I'll put a breakpoint on display and I will run the program. Yeah, here inside this debug area, you can see that ARR is an object of type array or a variable of type array. Size is 20, length is 5, and array A is of size 20, so it is showing all 20 elements. All the elements are 0, only first 5 elements are initialized. So I'll be using this example for explanation purpose. That's all in this video. In the next video, you can find the function for insert, and the program will be a same program. So inside the same program, I will be writing a function for inserting an element in an array. First of all, I will fill few elements in this array. So total I have 6 elements, so let the length of this array be 6. Now assume that already I have filled some elements in an array. Now based on this, let us look at these operations. So the first operation is to display. Let us see how we can display all the elements of an array. So first operation, display. Displaying or traversing an array is visiting all the elements of an array one by one. Now here I will show you the procedure by writing some pseudo code. It's not a complete function or a program. Afterwards we will see a complete program combining all these functions together. So let us see the logical part, how to perform the operation. So for that I'll be writing the code. Now for displaying the element, suppose I want to display only the first element, then I should say printf %d a of 0. This will be printing just a first element, that is at index 0. But if I want to print all these elements, then here I should use index. So for that I can traverse through this array from index 0 to 5 by taking a for loop. So for I assign value 0. So initially I starts from 0. So here I can use I. Then I should go till where? Till 5. So that 5 is the number of elements. So 0 to 5 I have total 6 elements. So I should say I is less than length and then I plus plus. So here L is capital. Now this piece of code will print all the elements. First time I value will be 0, so it will print A of 0. The next I becomes plus plus, I becomes 1, so it will print A of 1, then A of 2, A of 3, so on up to A of 5. Now here, instead of using a specific C language syntax, I prefer saying print A of I. So this becomes a pseudocode. Now this doesn't belong to any particular language. It may be C language or C++ or any language. So in C language it becomes printf, and in C++ it may be cout. So this is the method for printing. Now let us go to the next operation, add. So I'll explain that operation, then I will show how it works. Now second operation is add or append. Adding or appending is nothing but adding a new element at the end of an array, that is at the next free space in an array. So we have an array of size 10, but we have only 6 elements, so we have next free space at index 6. So who says that 6 is a free space? Because the length is 6. So 6 means number of elements. So I have 1, 2, 3, 4, 5, 6 elements. Last index is 5, but it is keeping the count of number of elements. So index 6 is a free. So it's very simple. Just in an array of length, I can store an element, whichever element is passed here. So I can store x. So suppose I wanted to insert a new element, that is a 10. So 10 is inserted here. Then now I have total 7 elements. So this length should also become 7. So let us change that length to 7. So I must also update length after performing this operation. So length plus plus. So this will increase the length. So adding an element or appending an element means adding an element at the end of an array. So it's a simple syntax, just 2 statements. So what is the time taken by this operation? The time taken by this operation is, if I say each statement takes 1 unit of time for execution, so just 2 statements are there, so the time is constant. We say time is constant. Now here I will tell you what is the meaning of this constant. So let me go a little bit detail here. See, the time that I got is 2, so function of time is 2. Now when the function is 2, then what is the degree of a function? So degree of a function is nothing but 2 into n power 0. So what is the degree? 0. So n power 0. So it is order of n power 0. So anything power 0 is written as 1. So that's why we write 1. So actually we mean n power 0. Instead of 1, we mean n power 0. So it's a constant. So the time taken, whenever you get any constant value, you got 2. So it's constant. If you get a 2000 also, it's constant. So whatever the figure may be, when it is a constant, so it's n power 0 and that value is 1. So we are not saying that this 2 is equal to 1, but we are saying that degree of a function is n power 0, that is 1. So this was the simplest operation. So we have finished how to display the elements and we have finished how to append. Now let us see insert. Next operation, insert. Insert operation takes index and the element. So this means inserting an element at a given index. So as an example, I have taken index as 4 and the element that I want to insert is 15. So it means I want to insert a new element, that is 15, at this place. But already some element is there. So I should provide a free space for that 15. So for providing free space, these elements should be shifted forward. Then a free space will open up here, then I can store 15. So for that, I should move 10, then I should move 9, then also I should move 6. Then a free space will appear here, then I can insert 15 there. So 10 should be moved here, 9 should be moved here. So how to do that same thing programmatically? See, I should start from last index 7, then standing there, I should copy the element from 6. So 10 will be copied here. Then move down to this location. Standing here, copy the element from this location. So 9 will be copied here. Then move I here. Standing here, copy the element from this index. So 6 is moved here. Then move I here. Then this is the place where we want to insert. So stop. When it became that equal to 4, then stop and insert the element there. So for that, I will write on the code. I has started from 7, that is length. So let I is starting from length. So I have to do this repeatedly. So let us say for. Then how long it should continue? While I is greater than the index that I want to insert at. So this is index and this is x. So index. Then I should be decrementing every time. Then as I said, when I was standing here, so it has copied the element from here. So at a of I, we should copy the element from a of I minus 1. That's it. So being at index I, copy the element from index minus 1. Then move I decrement I, then copy the element from this index, then decrement I and copy the element from this index. So being I kept on some index, I is on some index and copy the element from the previous index. So this process has to continue until I reaches this particular index. So when I has reached here, then simply we can insert this element 15 there. So at A of index, means the index at what we wanted, copy the value 15. So 15 will be copied here. Now once this 15 is copied here, the number of elements has increased by 1. So this 7 should become 8. So it means I should also increment length plus plus. So that's how we can insert a new element at a given index by shifting the other elements and providing a free space for the new element. Now one more thing we should take care here before performing the operation. This index should not be beyond the length of an array. See, total elements I have from 0 to 7, total 8 elements I have. And if I say that I want to insert at index 10 or 11, it should not go beyond length, or even it should not go beyond the size of an array. That condition we should check first. If it is valid, then we should perform this operation. So we'll be taking care of all those things when we write down the complete program. Now let us analyze this one. How much time it has taken for inserting an element? So what is the work done? The work done is shifting of elements, then copying of element. Copying of element is a constant time, but shifting of elements, how many elements we are shifting? See, it is possible that right now there are 8 elements and I want to insert at index 8. So no shifting required, simply the element will be inserted here. So there may not be any shifting at all, that is 0 shifting. Or I want to insert an element at index 0. So index 0 means I should shift all the elements. So, and maximum shifting can be n. So we don't know how much shifting may be required. So either 0 shifting or n shifting, depends where you want to insert the element. If you are inserting at the end of an array, then no shifting is required. At the beginning of an array, then all the elements present in an array, that is, let us say n elements, all n elements we have to move. So the time taken by this procedure or this function is order of 1, that is minimum, and order of n, that is maximum. So minimum time is 1, maximum time is n. So whenever we mention the time, we try to talk about maximum time taken by any function or a procedure. So this procedure takes order of n time, but it is having minimum time as well as maximum time. So minimum time taken, we can call it as basic case time, and the cases we are inserting at the end of an array. And the maximum time can be called as worst case time, and the worst cases we are inserting at the beginning index of an array, that is index 0. So that's all about inserting an element at a given index. So we have finished this one. Now let us talk about deleting an element from a given index. In this video, we will see append function and insert function that we have already discussed. So already I have written this program. I have shown you this is structure, and this modified one, I have taken array of size 20. Let us make it to 10 so that we can see the contents easily inside debug area. And inside main function, already array is initialized and the size is 10, and also the present elements are 5. Now here I will write on a function for append. This append function will insert a new element at the end of an array. So it should take a structure array. As it is going to modify the array, it should be a call by address type, and this x is the value that we want to insert. Now append means just we will be inserting a new element at the end of this array. Right now the elements are 2, 3, 4, 5, 6, so a new element should come after 6. So before insertion, first of all we should check whether there is sufficient space or not. If ARR arrow, that is caps, length is less than ARR's size, then there is a free space available. Otherwise we cannot insert any element. So for inserting an element in an array A of ARR's length. So we can insert it at a position length and also increment length. The value X should be stored. That's all, end of the function. I will call this append function inside main function by passing address of ARR and the value that I want to insert is 10. After inserting the value, this display function will display the value. I should get the values that are 2, 3, 4, 5, 6 and 10. Let us run. Yes, the elements are 2, 3, 4, 5, 6, 10. So this display function is displaying all the elements up to the length of an array. Let us debug this program and see at the append function I'll put a breakpoint, then I will run. Yeah, here inside the debug area you can see the elements in an array are 2, 3, 4, 5, 6. And it's about to call append function. Let us go to append function. It will check the length and the size. Then it will store an element in an array. Now if I expand this array object, you can see that after 6 a value 10 is also stored. Back to main function, then display will display all the elements. So that's it, we have seen how an element is stored in an array. So this display will display the elements that we have already seen it. So let us stop the function. Now next thing, we will write a function for insert. We have already discussed a function for insert, so above the main function I will write a function for insert. So the function for insert returns void and the function name is insert, and it should take a parameter of type array by address because it's going to modify an array. The next thing is index at which we want to insert an element, and last is the value that we want to insert, the element that we want to insert. Before insertion, let us check whether the index given is valid or not. A valid index is from 0 to length of an array. So here I will check if index given is greater than or equal to 0 or not, and also this index should be less than or equal to ARR's length. This is valid index. If the index is valid, then only we'll perform insert operation. So for performing insert operation, we need a for loop. So for that, I will declare a variable I. Now here using for loop, we will shift the elements and provide a free space for a new element. Then we will insert it. I starts from ARR length greater than given index and I minus minus. I am writing the same code what I have shown you on whiteboard. And at A of I, as A is inside an array object, so I have to use arrow operator for accessing it, A of I minus 1. So the previous element we will copy it here at the current place. Then after this, in an array at A of the given index, we can write down an element, and also ARR's length should be incremented because we have inserted a new element. That's all. This is the insert function. Now let us go back to main function. Inside the main function, I have already shown you how to use append. Now let us see how to use insert function. For inserting, I have to pass array as a parameter, that is by address, and the index that I want to insert at index 5, that will be last index, and the value that I want to insert is 10. Then after that, all the elements will be displayed. So this 10 should be inserted after 6, because if you see the indices, this is 0, this is 1, this is 2, this is 3 and 4. At 5th index the element will be inserted, that is after 6. Let us run and check. Yes, 10 is inserted at the end. I will change the index. I will insert it at index 0. Let us run it again. Yes, 10 is inserted at index 0, that is the beginning index. Let us change the index once again and see 2. 2 means it should be inserted in between 3 and 4, that is after 3. Yes, it is in between 3 and 4. The value 10 is inserted. Now let us give the index as -2, then let us see what happens. I run again. and the values are displayed. So 10 is not there. I'll give the index 9. Now let us run the program. See, still 10 is not inserted because the index was invalid. So that's all. In the remaining videos, I'll be using the same program. So it is having all the functions and the structure of an array available here. Delete operation is removing an element from a given index. Obviously, when we want to delete something, then we should mention which element we want to delete. So we can mention index. So as an example, I have taken delete element 3 at index 3. So this element I want to delete. So for deleting this element, so first of all, you take out the element from there. So taking out an element, so I can take out x assign a of this index, whatever the index is given. Now we have an element that we want to delete that is present here in x. So let us say 12 is present in x. So we have taken out the copy of an element. Now when we say this element is not there in the array, then this space will be blank. So remember this, we don't leave blank spaces in between the elements in an array. So if you are saying that that element is not there, then we don't know what all the other elements are there or not there. So then it becomes difficult for us to find out whether the element is there or not there. When we delete the elements from an array, then that space we don't leave it vacant. If we are leaving it vacant and assuming that the element is not there, then for every location we have to check whether the element is there or not there. So it increases our work. So instead of keeping that space blank, we will shift all the elements. So whenever we delete an element from an array, we have to shift the element to occupy that blank space. So what I have to do is shift the elements from here. So being here, let us again take I, which will shift the element, then move I and shift the element, then move I and shift the element. So it's going in forward direction now, and move I, then shift the elements. I should not move further because this is the last index where I have an element that was length -1. So I should stop before length -1. So I should shift all the elements one by one, starting from a given index and reach till length -1 location or before length -1. So the shifting of these elements can be done using follow. So let us start I from the given index, and being I here, it can copy the element from the next index. So let us write a for loop for I starts from given index. This is the index is 3. So from index, and where I should stop, it should stop at 6. Being at 6, it can copy the element from index 7. So I should be less than length. See, actually length is 8. Less than length means 7. No, it should stop at 6. So length -1. And I is moving forward every time. So I plus plus. Now what I has to do? Being here, it should copy the element from next index. So at A of I, it should copy the element from A of I plus 1. That's a loop. Now with this loop, I here at index 3, it will copy 15, then I plus plus, then being here, it will copy 6, that is +1 is copied here, then I plus plus, now I is here, so it will copy the element from next index, so it is at 6, so it is at index 5, so it will copy 9, then I plus plus, it should copy 10. Then after that, I should stop. Yes, I is less than length -1. Length -1 is 8 minus 1, that is 7. So I is 6 now. 6 is less than 7. So if it becomes 7, it will stop. So this has moved all the elements or shifted all the elements. So this element is removed. Now as the number of elements has reduced, so this should become 7. So here I should decrement the value of length minus minus. So this is the pseudocode for deleting an element from a given index. Now one more thing we should take care that the index should not be out of the range. Like I have only 8 elements, I am giving index as 10 or 12. Beyond the length of an array, it should not go beyond the length. So that you have to take care. So that we'll be doing it when we write the program. Now let us analyze how much work is done here. What is the time complexity? See, copying the element from a given index takes 1 unit of time, and decrementing length takes 1 unit of time. And this loop, the statement that is shifting the elements, how many elements are shifted? So it depends what index I have given. So minimum 0 elements are shifted. If I was deleting the last element, then nothing has to be shifted. If I am deleting the first element, that is index 0, then all have to be shifted. So minimum shifting is 0, maximum shifting is n. So minimum shifting is 0 or maximum shifting is n. So again, the minimum time is a constant and the maximum time is n. So if I write minimum time is 1 plus 1, that is 2, and the maximum time is 1 plus 1, 2, as well as n. So n plus 2. So the best time is 2, that is constant. Worst time is n, that is maximum. So best case is what? If I am deleting the last element, no shifting required. Now right now, if I delete 10 from here, if I want to delete 10 from here, then directly 10 is deleted. No elements beyond 10, so no shifting required. So the best case time is order of 1. Worst case time is order of n. So that's all about deletion. So we have finished deletion. Now next will be search. So we'll learn about search. In this video, we will see delete operation upon an array. So I'm using the same program which we have already used for insert, append and display. This is the array structure having array of size 10 with the size and length. So here, just above main function, I will write a delete function. Delete function will delete an element from an array from a given index. So it should return a deleted element and the function name is delete. It should take a parameter of type array and it should be called by address because it's going to modify an array. And the next thing is it should take an index from where we want to delete an element. Here I am getting an error because function should return something. So I will write return 0 for time being before writing the code. The error is gone. This IDE shows instant error. So wherever there is an error, that time only it will highlight the error. That's the benefit of this IDE. For deletion, I should take the value, deleted value in this variable. So I will make the variable initially 0. Then before deletion, first of all, I should check whether the index given is valid or not. So index should be greater than or equal to 0 and index should be less than equal to ARR's length minus 1. So or else I can say just index is less than ARR's length. So because if length is 5, we'll be having the last element at index 0. So this is the condition I have to check whether the index is valid or not. If the index is valid, then in variable x, get the value from array at a given index. Then I have to shift the rest of the values. So for that, I need one more variable I. I have declared the variable I. Now here, I will write on for loop for shifting all the elements. For I assign, from index onwards, I should start. And I should be less than ARR's length minus 1 because we are shifting the element, so we should stop at a length minus 1 and I plus plus. At every time at ARR's I should copy an element from A of I plus 1. This will shift all the elements. Then after shifting the elements, the length of an array should be decremented. So it is decremented. And I should return the value x, whatever the value is deleted. And here also, I can write x, that is x will be 0, or else I can write just 0 also. Means if the element is not found, means the index is invalid, then it will return 0. See, this is the extra condition I have written, checking whether index is valid or not. This I did not discuss in whiteboard session. Now, coming back to main function. Inside main function, I will call delete function. Delete will return the value that is deleted. See, here it returns integer type. So that value, I will directly print it. So let us write printf %d new line, then call delete function by passing address of array and index. I want to pass it at index 4. So last index is 4 and the value present there is 6. So I want to delete this value. Then after this, the length of the array will become 4 and I'll be having only 4 elements, that is 2 to 5. Let us run the program and see what happens. Yes, value 6 is deleted and now display function is displaying only 4 values because only 4 values are there. Let us give a different index. Index as 0. I'll give index 0. Let us run the program. So value 2 should be deleted and the remaining values in an array are 3, 4, 5, 6. Let us debug this delete function. I'll put a breakpoint on printf and run the program. Now watch here the debug area. The values are 2, 3, 4, 5, 6 and the value that I am deleting is index is 0. If I continue running, then what happens? Just watch it. It has entered into delete function. I will expand this array object so that we can see the contents of an array A. See, now for loop starts, so it will be shifting the values one by one. See, 3 is copied here. Now these two places 3 is there. So this 3 is copied here, 2 is gone. The next 4 will be copied here. So this 4 remain as it is unless it is removed. So we can't remove it. So this 4 will be copied here next. This 4 is copied. Then 5 is shifted. Then 6 is shifted. You can check the length also here at the bottom. Length is 5. 6 is shifted. Then length became 4. That's all. It will return back to main function. And the value is printed, deleted value is printed and the display function is called. So that's all with this delete function. Let us look at search methods in an array. There are two search methods. One is linear search and the second one is binary search. So in this video, we'll look at linear search and in the next video, we will talk about binary search. So let us look at linear search. Here I have a list of elements. I have taken a list size or array size as 10 and the list size is also 10. Now here I have taken unique elements. So for performing search, the elements must be unique. There should not be any duplicate elements. If there are multiple copies, then if you are searching, we may be getting any one of the copy. May not be able to reach another copy of it. So there should be unique set of elements. Then in a list, if I want to search for any key element, so the value that we are searching, usually we call it as key. So suppose I am searching for a key that is 5. Let us look at linear search method. In linear search, we search for the key in a list linearly by checking the elements one by one. For searching 5, we will start comparing from first element onward. Is it 5? No. Next, go to the next element. Is it 5? No. Go to the next element. Is it 5? No. 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 Yes, it is found here. We already know the element that we are looking for, that is 5, and we want to know where it is present. So we got the index, that is 7. So usually the result of a search is the location where the element is found, so that we can access that element. Now let us take one more key element and search it. So this time I'll take the key element. Key is 12. Let us find out whether 12 is present or not. So we'll follow the same procedure. We'll start from the very first element in the list and compare 12. Is it 12? No. Go to the next element. Is it 12? No. Go to the next element. The next, and even this is not 12, this is not 12, then we have reached the end of a list. So if we have reached the end of a list, means element is not found. If the element is not found, search is unsuccessful. So if the key element is found, we say search is successful. If it is not found, then we say it is unsuccessful. So this is successful. This is unsuccessful. So key element is found, this search was successful. Key element is not found, so this search was unsuccessful. So when you are searching, you have to take care of both the things, whether the element is found or not found. Now let us write a pseudocode for performing linear search. So for searching for a key element, we start comparing the element from the 0th index onwards, and every time we move on to the next element, so it is just like traversing a list. This can be done using for loop, or even if you want, you can use while loop. So I'll first show using for loop. So for I start from index 0, so I should start from index 0, and till where I should go, till the end of a list, and the index is 9. So that is length. Length is 10. So it is length minus 1. So I can say I less than length. So I should traverse the whole length of a list. And every time I should be moving forward. So I plus plus. Then what I have to do? Every time wherever I is, I should check that if the key element is equal to A of I. So if key is equal to A of I, if it is equal, then search is successful. So we got the element. So once you got the element, what we want the index where the element is found. So here we can say return index. So who is giving index? I. So wherever I is present, that is index. Return I. That's all. So let us see how it works. I is initially 0. Suppose the key value that I am looking for is 5. Then it will check I is less than length. Yes. Key, is it equal to A of I? That is key 5. Is it equal to A of 0? 8? No. So it will continue and say I plus plus. I will move to the next index. Then here it checks key, is it equal to A of I? 5, is it equal to A of I? That is A of 1? 9. No. So it will go to the next. So it will continue. And once it reaches here, now this time key is equal to A of I. Yes, 5 is equal to A of 7. Then return 7. So this is in case of successful search. Now what happens in case of unsuccessful search? Let us see. Initially I is 0. Suppose we are searching for 12. First it will check that key is equals to A of 0. 12, is it equal to this one? No. Then I will move to the next element. Then check key is equal to A of 1. A of 1? No. Then again I plus plus, I moves to the next element. Then again check 12, is it equal to A of this? No. So in this way it will continue, and this condition will never be true. So I will move to next, then next, then next, then finally let us take this. I is less than length. Yes, length is a 10, and I is 9. Yes, it is less. So key, is it equal to A of I? 12, is it equal to 2? No. Then continue I plus plus. I will move to the next location. Now I became actually 10. This I became 10, and 10 is not less than 10. So it will come out of the loop. So if it is not finding a key element, then it will come out of the loop. If at all key element is found, then it will return, means stop the procedure here itself. So if the key element is not found, then it will come out of the loop. Then outside the loop we can say return. Now, if the key element is not found, then we have to return something to show that element is not found. So the invalid index, that is -1. So we can return -1. So usually we do it like this. If the element is not found, then the return index is -1. So if you are calling this procedure, then if you got -1 means element is not found. If you got a valid index means element is found. So that's how you can know whether the search was successful or unsuccessful. So this is about linear search. Let us analyze, find out the time complexity of linear search. So one thing I will tell you about time complexity. So for finding the time complexity, either you can observe the work that is done, or else you can read the code. So let us see from the procedure. What we are doing for searching: key element, checking, next check, next. So we are comparing the elements. How many elements we are comparing? At most how many? See, if I am searching for 2, then I may be performing all n comparisons, means depending on the number of elements. Or if I am searching for 8, then I may be getting an element in just one comparison. So if you look at the code now, this loop may repeat up to the end of a list, or if at all the condition is satisfied in the beginning itself, it may terminate. So this loop may repeat minimum for one time and maximum for n time. So the best case is that if the element that we are searching is found at first place and the time is order of 1. Best case time is 1. And the worst case is if you are searching for an element which is present at the last index and the time is order of n. So worst case is searching for last element, or the time taken for worst case is order of n. This is case of successful search. What about unsuccessful search? If the key element is not found, then always it will check all the elements, then only it can inform you the element is not there. So for unsuccessful search, time is always order of n. It's maximum time, always maximum time. So unless you have reached the end of the list, you cannot say that the element is not present in the list. So the time taken is order of n. So this was the best case and worst case I have shown you. Now one more thing. Let us look at average case time also. Average case time may not be easy always, so we may not be performing it always because it needs a lot of efforts for doing analysis. So mostly we are dependent on worst case or also best case. Now let us see average case. Let us check. So best case is searching for an element present at 1. Worst case is searching an element present at last. Then these are two cases. What are the other cases? Searching for an element present at index 1, that is second element, or the third element, or the fourth element, or the fifth element. So these are all possible cases. Then what is the number of comparisons done for checking if the element is present? Then what is the number of comparisons required if you are searching for first element? Just one comparison required. Then what about the element at second location, that is index 1? Two comparisons required. So the case if you are searching for this, it needs two comparisons. In case if you are searching for this, it needs 3 comparisons, so on. Then if you are searching for last element, n comparisons are required. So I have taken the time taken in all possible cases, and I have taken the total time taken in all possible cases. So sum of the times taken in all possible cases. Then total how many cases are there? N elements are there. So n cases are there. So this is n. So sum of the time taken in all possible cases divided by number of cases. This is equal to n into n plus 1 by 2 whole divided by n. N gets cancelled. So this is n plus 1 by 2. So this polynomial is degree 1, that is order of n. So the average case time is order of n. So we have found the average case also. Now, let me say something here. See, usually finding average case time needs a lot of analysis. So you have to consider all possible cases, identify them, take out the time and add their times and divide them by number of cases. This is a little tedious work. And sometimes we may not be able to get some proper solution. So mostly we are dependent on worst case, because usually worst case and the average case will take same amount of time, almost same amount of time. So worst case is easy to analyze. So mostly we do worst case analysis. So this was the analysis of linear search. Now let us see improvement in linear search. Is there any improvement possible? Let us check. So it is observed that when you are searching for any key element, then there is a possibility that you search for the same key element again. For example, if you have a collection of books in a shelf, that is your personal collection, you have searched for a particular book and you take out the book and read it, again you keep it back. What is the possibility that again tomorrow you will search for the same book? The possibility is high. So that's what in the search, the behavior of search is that when we search for something, possibility that we search for it again. Then when we are searching for 5, how many comparisons it has taken? Total 8 comparisons we had performed to reach 5, that is 0 to 7. Now, if we are searching for 5 again, then what we want is it should be searched faster. So there are two options. One option is you can move 5 to the previous location, just one location. You can swap 5 with the previous element. So it will reduce by one step. So second time when you are searching, you have to perform one less comparison. Then again if 5 is searched, then again it will move. So every time whenever you are searching 5, then it will be coming closer and closer. Now 5 is moved here and 10 is moved here. So let us write like this, 5 and then 10. Now again if you are searching for 5, then 3 will go there and 5 will come here. So if you again search, it will again move closer. So you can move a key element which is repeatedly searched, you can move it one step forward. So this method is called as transposition. So that transposition you can do it here. If that key element is found, then you can swap that key element with a of I with a of I minus 1. And now your key element has index I minus 1. Then you can return I minus 1. So this one statement you can add inside search procedure. So if the element is found, so it is moving one step forward so that next time it can be searched faster. This is one method. Now second method I will show you. Second method is if you are searching for a key element which is found here after performing 8 comparisons, then once it is found, you bring it in the beginning. Swap it with the first element. If you are swapping with the first element, the next time when you are searching, it will be found just in constant time. So this method is called as move to front or move to head. It is also called as move to head. Move to front or move to head. So this is another suggestion or another guidelines for improving linear search. So here in this code, if the key element is found, then we can swap the element with index 0. And now the new index is 0 for this element. So 5 is brought here. Let us assume 5 is here and 8 is here. So the key element that we have searched is brought in front. So you can return index 0, that the element is index 0. So this is another method. In transposition, the elements will be moving slowly forward, or if it is not searched, then it will be slowly moving back. This is how it behaves. Then in move to front, if the element is searched, then directly it is brought into the first position. Suppose now if you search for 2, then 5 will be sent on that index 9 and 2 is brought here. So we don't know where the present element like 8 will be thrown away. But the new element will be brought at that index. So then again this may be thrown away somewhere else if you are searching for some other value. In transposition, there is a slow reduction in the time taken for searching. And in move to front, there is a sudden reduction in the time taken for searching. Next time if you are keeping on searching, it will be done only in constant time. So that's all about linear search and in its analysis.